Okay, I'm going to go over exercise 6.2 audio systems for you. I've just written the equations on there for you that you will need. Now, I prefer using the bottom equation, which is just the bog standard gain is V out over V in. However, there is an equation for a summing amp just above it, which is V out equals minus RF, open up your bracket, V1 over R1 plus V2 over R2 plus V3 over R3, etc. Okay, so I will mix up and use both of them, and then you can obviously decide which one you prefer. Okay, so look at that first question now. It does say that the variable resistors are set to 10k for channels 1 and channel 2. Channel 3 is set to 40k. So don't be fooled by the way it says 20k there. It says it's set to 10k. So I'm just going to write 10k. 10k, strictly speaking, should be omega sign. And then what was this one? 40k. Okay. Okay, so let's use the equation first, the top one, the one that you may well prefer to use, which is on a data sheet. So we're going to write V out equals minus RF minus 30. Open up your bracket. V1, which is channel 1, obviously, so 1.6 volts. Look, is that okay? Yeah, 1.6 volts over R1. Well, R1 is 20k, so it's 10 plus 10. So R1 over 20. I can put K there, but I'm just going to leave it like that because the Ks would cancel anyway. Plus 1.2 over 20. Feel free to pause me and write the third one in if you want. And then obviously you can unpause me. Plus 2.8 over 60. Does that make sense? 40 plus 20 is 60. Okay, press equals on your calculator to push them all in. You might want to just try this yourselves. Minus 5.6 volts is your answer. Okay. Okay, so for this next one, I'm now going to go the other way, using the gain is V out over V in type thing. So I'm basically going to say, I'm going to work out for channel A first. So I'm going to say that the voltage, I'll just call it, I'll call it V1 because it's not strictly speaking V out yet. Is going to equal V in. I'll just write the whole thing, V in times gain, just so you can see where it comes from. So V in would be 1.8, 1.8 volts, because that's what VA is, multiplied by the gain, which is obviously 150 over 150. I'll write it out if you want. But we know that that's obviously going to be 1. It is negative, strictly speaking. Yeah. So your final answer for that will be minus 1.8 volts. For V2, it's going to be, where are we? 2 volts multiplied by your gain. Gain is 150 over 300, which I know is a half. So 2 times a half is 1 minus 1 volt. So V out equals, add the two together, minus 2.8 volts. That's the other way to do it. So you can just do that and add the 2 at the end, or you can stick it all in one big long equation. I actually prefer, as I say, the second one. I prefer this method, but it's entirely up to you, however you want to do it. Okay, so that's basically just gain, V out equals V in times gain. Okay, moving on. Right, I'm just going to write the gains that we had from the previous question. Notice for this bit, it's basically saying that we've now got sine waves applied. We need to work out V out. So we actually do need to know the gains for this. If you did this method up the top here, you wouldn't know the gains. Whereas if I do this method down here, look, I've worked out just there. I've worked out the gain, haven't I? Yeah. So I know the gains. So I'm just going to write the gain for A was it was minus 1, and the gain for B was minus a half, minus 0.5. Okay. Right. If it was just plotting VA, it would have a gain of minus 1. It would literally be the same signal, just inverted. Yeah, it would be the same signal inverted because it's just a gain of minus 1. If it was just plotting VB on its own, it would be The same signal multiplied by a half. So if you've got -4 going in, it would therefore be -2, because that's half of that, but inverted. So it would just be sat at 2 volt. So that would be VB if it was just on its own. Because it's both of them together, it's literally going to be sat there, and it's going to be the same signal for A inverted like that. And there, that's added the two together if you think about what I've done there. Plotting that down to there, plotting that up to there. That's literally the two signals. Oh, that's literally the two signals added together. Let me just show you where that comes from again. I'll do it in a different color just to show, prove that that is the case. Let's go for a nice pastely green, shall we? So if it was just VB on its own, it would be settled there. If it was just VA on its own, it would be centered at 0, inverted. It would be about there-ish. So can you see by adding the two lovely pastel colours together, it would be the same as setting the signal at 2 volts. So it basically shifts it to set at 2 volts. I hope that makes sense. It's the blue one that's the answer. That's what you're looking at. Okay, that's the answer there. Okay. Okay, let's have a look at this one. So this time we've got variable gains. Look, the key for variable gains is to work out the highest one first. Always work this one out first. Variable gains tells me what sort of resistor do you need. Yes, you do need a variable resistor, but you also need a fixed resistor. If you just had a variable resistor, then obviously if that variable resistor went to 0, down to 0, you'd have an infinite gain, which wouldn't really be beneficial for anybody. So you still need a fixed resistor in there and a variable. Right, so I've said work out the variable resistor first. Can I make this a bit bigger actually? Bit more space to write. So work out the variable resistor first. So for a gain of 1, that would therefore be 150 kiloohms. Think about it. This variable resistor can vary from 0 ohms. If that was 0 ohms, the gain would be 150. I need to now vary that. If I increase this, look at the equation. I'll just show you, just so you can see, Dan, what you're talking about. If Rin gets bigger, what's going to happen to the gain? It's going to reduce, yes. So Rin bigger, gain reduces. So I need a value to increase that to give me a gain of 0.1. Is everybody happy, therefore? To give me a gain of 0.1, if I have that as 150, a gain of 0.1, I need that to equal 1500 to give me the 0.1. Yeah? Okay. So what would that have to vary to? Have a think about it. Does that make sense to everybody? Why it has to vary from 0 ohms up to 1350 kiloohms? Yeah? Because if you add the two in series, that will give me a 1500. So work out the highest value first, and then obviously the variable resistor will only reduce it, so you can work out the lower value. Dead easy. Okay. This is dead easy as well. This is just basically showing you about, so a circuit diagram for a mixer. Okay, so we're looking at those values. We want to design a mixer. Does it need to be variable? Just having a little look there. No, it doesn't even need to be variable. Look, they're fixed gains. So it's bog standard, feedback resistor to there. That goes to there. Input resistors connect together, connect to there. Where does the positive signal go? Obviously, it always goes down to 0. Just about fit it on. Okay, and then label any values. So I'm going to work out the highest gain first. As I said before, always the highest gain first. The minimum input impedance has to be 10k. So I'm going to make that one a 10k resistor. The gain for channel 1 has to be 10. That would therefore be 100k. Channel 2 has a gain of 5. I can do that in my head. If you're stuck, stick it into the equation. But I know that that value has to be a fifth of the output. Yeah, gain is minus RF over Rin. That's where it comes from. So that'll be 20k. Okay. So no excuses for that one, really. Hopefully that's nice and easy for you. I've done that bit. And then finally, this is all about maximizing the bandwidth. Remember, the lower the gain, the higher the bandwidth. That's why we put two stages together. So in order to optimize the bandwidth, we need the lowest gain possible. Literally take the square root of 900, 30 and 30. Think about it. 30 times 30 is 900. If I went for something like 450 and 2, that would be rubbish because that's still quite a high gain. The best case scenario you can ask for is take the square root. Can we work out the bandwidth? Of course we can. This is bog standard stuff. Look, gain bandwidth product is gain times bandwidth. We want to find the bandwidth. So the bandwidth, I'll put therefore. Therefore, the bandwidth is gain bandwidth product over gain, which is in this particular case 1 megahertz over 30, which is obviously a 30th. Where are we? 33 kilohertz. Okay. So that is it. So I will go over this in lesson, but obviously I would like you to look at this in your own time as well. When you have watched this, please do rate it. Just you know, put a love heart or just put a little comment in there saying, yeah, I think it's about a 6 out of 10. I think it's about a 10 out of 10. Just so for your understanding, not the quality of the video, it's your understanding, just so I can A, see that you've watched it, and B, sort of gauge how these videos are going in terms of your understanding. Okay, thank you very much.